Hey everyone, this video is about attempt to repair this fan. This will be one of two. There's another one I've got. Had a coworker had a couple of fans that broke and just started malfunctioning and they don't come on. So like for example, this plugged in and turned it on, nothing happens. So he was going to throw them away, but me being a sucker that I am, I'm like, hey, I'll take them and then try to fix them, and if not, I'll just get rid of them. So this is a video about me trying to see what's wrong and if possible fix this. So I don't know, I can have yet more fans since I already have a bunch. I'm going to disassemble this and then I'll be back in a moment. Alright, I've got it partially disassembled. I've got the motor out, got the front off. It's not plugged in. That would be really not the brightest thing in the world to do right now. Do have the plug, so first thing I'm going to do is I'm going to check continuity from the plug to the line side of the switch. This is a 4-position switch. Off is, assuming I'm doing this right, all the way over here. Then that's 3, 2, 1. They have 1, 2, 3, 4 positions coming out. There are 3 positions coming out of the switch. I've already done some testing, but I'm going to show you what I found. So the first thing I'm going to do is I'm going to check continuity, which means that for the most part you can assume that there's no breaks in the line all the way up to a point. So I'm going to check one side, which is this. It's good. So this plug is only, this pole of the plug is only going to go over to this line. So I'll switch over to the other, and with the switch off, because it's in, I think that's right, the left position, you should get, I think it's just one on. So if we check this pole, nothing, check this pole, nothing, and we check this pole, nothing. So that's off. So now if we switch it to, let's go all the way to the right for position 3, or position 1, it's kind of weird. Well, let's see, we get anything here? We get some resistance, continuity there, continuity there. So that's working. Then we get to the next one. Sorry, you can't really see the, yeah, you can see it now. Now if we switch it to position 2, we get continuity there, continuity there, continuity there. So pretty much right there we can probably stop. This means that the switch and the lines going from this plug all the way to this point are at least good. At that point we know that we're getting current through, if we actually plug this in, we would actually see current going all the way up through at least here. So unless there's a break in the line, or a short inside the motor itself, pretty much up to this point we're all pretty good. The other thing is, of course, we got this capacitor. It is a 3 microfarad capacitor, pretty big one. They've got it potted, and they've got this little mounting point which goes in the bottom of the housing here. So what I may do, it's just a guess, but my thought would be it's maybe the capacitor's bad. I might go and cut these lines here and then test the capacitor independently of the circuit, because there's nothing bare, so I can't just test it like you normally would, because usually you'd have like a pair of pins and you could get your leads in pretty easily to like test it. But since it's all potted and inside and there's nothing exposed, I can't really test this capacitor. But I'm going to go and try that out and take a look, and I'll be back shortly. Alright, I cut the capacitor out, hooked it up to my LCR meter, and it's rated as a 3 microfarad capacitor at 5%, plus or minus 5% tolerance, and as you can tell, it's well within its rated capacitance. It's almost 3 microfarads, just a little bit off, 0.002 of a microfarad less, which is pretty good. There's nothing wrong. Like the ESR is very low. So, I mean, the only thing I can say is this capacitor is fine. There's nothing wrong with it. I'll check it on my multimeter off camera, but so far it's looking like there's probably something wrong with the winding itself. Maybe there's a short in it, in which case this thing's pretty much toast. So anyway, I'll be back again shortly. Just as a follow-up to make sure I'm not missing anything, I tested it at a higher frequency, so I said let me just double check and run it at 120 Hertz, since that's what this is powered under, and it's even more on to its rating. It's even more correct. It's 3 microfarads. So at this point it's clearly not capacitor. it's definitely not the problem. Anyway, back shortly again. Alright, I took the motor and the fan blade assembly itself out. I disconnected this line, and then I just cut this one that runs from the plug. This is the one that I disassembled, and then this one I cut. I mean, after all, it's already not working, so it's not like I can make it any worse. This is a switch. So I also went ahead and unscrewed the front of the motor, and then of course here's your rotor, and then this means you can free the back, and then of course here's the stator. You can see the field winding in there, and of course the cores and the lamination. I'm going to dig around some more. I think I want to go and try to pull this open, the lines coming in, and try to see if maybe I can find out why it went. I mean, at this point, I think unless I see something painfully obvious that I can fix and hear, I think this thing's toast. It's kind of too bad, of course. You know, you never really want to see anything break. But I might scavenge like the switch, because after all, it does work. I don't really think there's anything else worth keeping if I can't figure out why it stopped. Anyway, I'll be back shortly if I find anything. If not, I'll say, hey, that's it, it's done. Anyway, back again. Alright, back. I pulled this out. Here's the paper itself that's come out. I think I may have a pretty good idea what happened. When I pulled open, I found this component here. It's got a rating of, let me see if I can look at it. Hang on, let me read it. A rating of, I have a code on it. It says AUP0, A2F, 150 degrees centigrade, 2 amps, 250 volts. I guess would be at some form of thermistor or fuse or something like that. I'll have to go look it up. Regardless, I think that's what's bad. So where it's connected at is this blue line, and then it runs right through here to this line, which is the black line that then runs into one end of the windings. And remember, this one goes back to the switch, if I remember right. Or maybe it's this way. No. Anyway, my thought would be that this is what actually cut off, and because of that, this is what's probably killed it. What I'm going to do real quick is strip it, and then when I'm going to come back in a second, we'll see if we got continuity through this, whatever it is. Hang on, I'll be back in a second. Alright, I'm back. I looked up this part. It is a non-resettable thermal cutoff, aka basically a fuse, for temperature protection. So what happened was this thing probably got overheated, and this thermal cutoff kicked in and cut off, and since it's a one-shot, it blew out, and that's why this thing died. Now the question is, really, why did this thing get that hot? I actually kind of have a theory about that, or I guess a hypothesis. And I know, by the way, there are tons of these out there. I found you can buy 5 pieces of this exact model and manufacturer for like $6 on Amazon. There's other places, of course, that sell them. They're readily available, so these are an active part. So in theory, I could try to fix this. I mean, I might. It's certainly just be interesting to see if I could. Anyway, I do think I have an idea why this thing failed, though. I noticed that the fan itself, when I was actually trying to spin it, it was really stiff. Usually when you spin a fan, it'll just spin, freely. This one is not, and I think the problem is it's this bushing. It seems to be just really sticky. It's just not the front, which, like I'll show you here, this is the front part of the motor. That spins just fine, quite easily, right? So, you have to think about it. This is sitting, this is the rotor, the stator's here, current's going through, generating the magnetic field, etc., etc., and this thing is spinning like this, right? Well, that spins easily, okay? Well, that's what you would expect. But this, on the other hand, if I put this in here, it's kind of hard. you can see I can't spin this at all. So my guess would be that, here, I'll do it from this way. This thing should spin as freely as this is. So my thought would be that the reason why this died is this bushing, because it's not a bearing. This bushing is really quite poor. I mean, it might be worth it taking a look. I don't know. I can certainly put it back together. It's not that difficult. If I replace this fuse, I mean, it can certainly function again, I think. I mean, I'd have to go and reattach all the wires, strip them, solder them, heat shrink them, etc., which I can do. And the part itself, I mean, I got 5 of them. You get it for like $3 or something. They're cheap. I mean, I suspect I could go to like DigiKey or Mouser and get them even cheaper. But I don't know if it's worth the trouble, and especially if this thing is messed up. So anyway, I think that's it for now. If I decide to fix it, I'll have a part 2 to this video, and we'll see how it works. Anyway, hope you enjoy that. This is just kind of more of a dissection. I won't say this is really pretty much a repair video. It's kind of like just a, I guess, a post-mortem of a failed fan and what happened, what went wrong with it. Well, if you like this, you can subscribe and get notifications. Like it, don't like it, comment, don't comment. It's up to you. Anyway, thanks for watching.